Hello, guys. Welcome to Ramta Solutions. Welcome to your work, energy, and power examination prep. The question paper that we are looking at today is the Eastern Cape's June examination of 2024. So, as you guys can see, this question paper is 16 marks, so we should be done with it in 16 minutes. So, without any waste of time, let's get into it. Let's see. The diagram below shows a boy skating on a ramp which is inclined at 30 degrees. Okay, I can see that to the horizontal. A constant frictional force of 50 newtons acts on the skateboard as it moves from point A to point B, from A to B. Okay, consider the boy and the skateboard as a single unit of mass, 60 kilograms. So the mass is 60 kilograms. Okay, ignore effects of air friction. All right, cool. 6.1, draw a free body diagram showing all the forces acting on the skateboard while it is moving down the slope. While it is moving down the slope, we know gravity will be perpendicular to the ground, and then normal force will be perpendicular to the surface, and then friction opposes motion, right? So this is the free body diagram that you can draw. Okay, perfect. 6.2, and by the way, you can also draw the free body diagram in this way, where you can say you have normal, then FGY, and then oops, which way? No, not this way. I forgot. Normal is the other way. So normal is this way. Okay, so it'll be normal, and then it'll be your perpendicular component of gravity, and then it is your friction, and then it is your horizontal component of friction. You can also draw your free body diagram in this way. Okay. 6.2, use energy principles to calculate the speed of the boy skateboard unit at point B. So we're looking for the velocity at point B. So when it's like this, I like using the work done by non-conservative force formula. So W and C, this formula is given, guys, is equal to change in potential energy plus change in kinetic energy. Remember, this formula is provided in your data sheet. Okay, so what is this? The non-conservative force that we know is the friction, delta x cos, I'm going to say theta, is equal to, what do we do? Is equal to change in kinetic potential energy. It'll be, let's just say mg, and then it'll be height at B minus height at A plus half m change in kinetic. It'll be speed at B square minus speed at A square. Close. All right. All right. Perfect. Now, let's see now. So we are given our frequency, our frictional force is 15 newtons. So it's 15. What is the thingy? What is the displacement? It is not given, but we can see that this is opposite and this is hypotenuse. So we know sine 30, not theta, sine 30, let me use a different color. So we know sine, come on, buddy. So we know sine 30 degrees is equal to 10 over delta x. Therefore, delta x is 10 over sine 30 degrees, right? So if you like, you can substitute this value if you like, you can substitute this value here and say this is 10 over sine 30. Now, friction opposes motion. It will be cos 180 degrees. The mass of the boy and the skateboard was 16. So it is equal to 60 times 9.8, open bracket. The height at point B is, remember, the height at point B is 0. And then the height at point A is 10 meters. Okay. Plus half, the mass is 60 kilograms. What is the speed at point B? It is what we are looking for. The speed at point A. What is the speed at point A? We will take it as 0. It's not given, so we will take it as 0. Okay, we will take it as 0. Right. So, oh, the frictional force was 50, guys. So 50 times, I think it'll be 20. 50 times 20 will be negative 1000, isn't it? This part is negative 1000. And then 60 times 9.8 times 10 will be, it'll be negative 5880 plus 30 v sub p squared, isn't it? Now we have 4880. 5880 goes the other side, right? So it'll be negative 1000 plus 5880. It becomes 4880. This is equal to 30 v sub p squared. If you divide this by 30, otherwise you can get your answer directly, right? You can get your answer directly, okay? But let's do it step by step for those that somehow make those mistakes. So let's see. This will be so this will be, let's see, when you divide 4880 by 30, what is the answer? Let's say it'll be, because I don't like working, okay, maybe let me just do it. No, but I don't like working with decimals. This will be 488 over 3 equals v sub b squared. Now the square root of this guy, will be b, v sub b is equal to the square root of 488 over 3. Therefore, v sub b is 12.75 meters per second. That is the speed at point B. Okay, that is the speed at point B. All right. Okay. Now, then let's find 6.3. Point C. Let's look at the diagram. Point C is delta x meters to the left of point B. Okay. The boy skateboard unit comes to rest at point C. The coefficient of kinetic frictional force mu sub k for the surface BC is 0.15. 6.3.1, state the work energy theorem in words. What is it? The work energy theorem says the net work done on an object is equal to the object's change in kinetic energy. This is 6.3.1, isn't it? So 6.3.1, the net work done on an object is equal to the object's change in kinetic energy. Change in kinetic energy. All right? Now 6.3.2, let's see what it's asking us. Use the work energy theorem to calculate the distance delta x that the boy skateboard unit moved before coming to rest. So here, what do we have? we have final velocity rather, right? We have the final velocity, which is 0, and we have the initial velocity, which we calculated 12.75, or initial speed, all right? Initial speed. So let's go now. We're going to use the free body diagram for this system. It's normal force, gravity, right? It is normal force, gravity, and friction. There is no other force that's acting on the system. Can you see that? So we therefore say net work is equal to change in kinetic energy. What is that? Friction delta x cos theta equals half m, if you like. Okay, it's B and C, okay? Half C square minus half M V sub B square. So what is the friction? The frictional force was 50 newtons. Is it? Is the frictional force 50 newtons, guys? Oh, no, it's not. So in this case, it is not 50 newtons. It was 50 for the surface. Here they gave us the coefficient of kinetic friction. So it's okay. We have to change this part. We have to change this part and say you are mu mg delta x blah blah. Right? Why? Because kinetic frictional force is equal to mu sub k multiplied by the normal force. In this case, the normal force is mass times gravitational acceleration. Okay, so what is it? It is 0.15. Okay, it is 0.15 times the mass was 60. Gravitational acceleration is 9.8. What is the distance? It is unknown. Cos friction opposes motion, so it'll be 180 degrees. Now the object stops at point C, so it is 0 here. And then we still remember that it was the speed at point B, it was 12.75 meters per second, isn't it? Okay. Now 0.15 times 60 times 9.8 is, by the way, times cos 180 is negative 88.2 equals negative, oops, do not forget the delta x. Delta x is equal to negative 30 times 12.75 squared. What is that? This is negative or 4,876.875. Now this divided by 88.2, what is our delta x? Our delta x is 55.29 meters. Okay, it is 55.29 meters. Remember, guys, this formula was the game changer for this question. Okay, so we were done in less than 16 minutes. Can you see that? We're done in less than 16 minutes. Right. So this is it, guys. I hope you now see how to master this. So, bye-bye.